Before we jump into the topics, imagine a large e-commerce company struggling to manage millions of daily orders, predict customer demand accurately, and optimize warehouse operations. Manual forecasting often led to stockouts, delayed shipments, and unhappy customers. Now imagine a system that can analyze massive amounts of data in real time, predict demand patterns, optimize inventory, and even suggest the best delivery routes. That's where AI comes into play in supply chains. As we have seen that AI, or artificial intelligence, is a branch of computer science that enables machines to mimic human intelligence. In this process, AI learns from data and make decisions or recommendations. Let's talk about something that often creates confusion but is actually quite simple once you understand it. Machine learning is a subset of artificial intelligence. Deep learning is a subset of machine learning, and generative AI is a subset of deep learning. Now let me explain this step by step with simple examples so that it stays with you for a long time. Artificial intelligence, or AI, is the broad field where machines are designed to perform tasks that usually require human intelligence, like decision-making, understanding language, or solving problems. Within this, our first subset is machine learning, or ML. Machine learning means the system learns from data and improves itself over time without being directly programmed for every possible outcome. For example, in supply chains, ML can predict demand by studying years of sales data and seasonality trends. How does it work step by step? First, data is collected, then algorithms are trained on this data, next predictions are made, and finally the model improves as new data comes in. Some well-known ML tools include Microsoft Azure Machine Learning, Google's TensorFlow, and Scikit-learn. Now let's talk about the next subset, which is deep learning. Don't worry if this sounds complicated. We'll make it very simple. Deep learning is actually a special type of machine learning. It uses something called neural networks, which are inspired by how our human brain works. Think of it like this. Our brain has millions of tiny switches called neurons, and they pass signals to each other to recognize things. For example, when you see a dog, your brain doesn't instantly say dog. First, your eyes notice shapes, then colors, then ears, then legs, and finally your brain puts it all together and says, yes, that's a dog. Deep learning works in almost the same way. It uses multiple layers of small decision-making points, like steps, that slowly understand the data. That's why we call it a multi-layered neural network. Let's take a super easy example. Imagine you give a computer a lot of pictures, some of cats and some of dogs. At first, it doesn't know what's what. But the first layer of the neural network looks at simple things like lines or edges. The next layer starts noticing patterns like round faces or pointy ears. Another layer checks tails and shapes. Finally, after passing through many layers, the computer learns to say, okay, this picture looks like a cat, or this one looks like a dog. So simply put, deep learning is like teaching a child. At first, the child just sees random shapes. Slowly, they learn step by step, and one day they can identify a dog, a cat, or even your face in a photo. Deep learning is especially powerful for things that are not neat or structured, like images, voices, or videos. That's why it's used in face recognition on your phone, voice assistants like Alexa or Siri, or even in YouTube's recommendation engine when it suggests the next video you should watch. Another relatable example is when a logistics company uses deep learning to automatically detect damaged packages through camera images before shipping them. How does it work? First, raw data like thousands of package images is fed into the system. Next, multiple hidden layers in the neural network process, features like shapes and colors, then the network identifies patterns, and finally it predicts if a package is damaged or safe. Popular tools here are PyTorch, Keras, and TensorFlow Deep Learning libraries. Hopefully you can see, deep learning is nothing magical. It's just computers copying the way our brains learn step by step. Now moving further into the next level, we arrive at something very exciting. Generative AI. Don't let the name scare you. It's actually simple once you break it down. Generative AI is like the creative side of deep learning. Instead of only analyzing data and telling you what it sees, It actually creates something new from what it has learned. Think of it this way. Imagine you give a child hundreds of Lego sets to play with. After playing for days, the child doesn't just copy the exact models from the instruction book. Instead, the child starts building brand new houses, cars, or even castles from the same Lego blocks. That's exactly what generative AI does. It learns from a lot of examples and then creates brand new things. For example, generative AI can write text, like an essay, story, or even a professional email. It can create images, like artwork or logos. It can even make new sounds or music. And in factories or supply chains, it can be super useful too. Let's take a simple example from manufacturing. Suppose you need to design new packaging for a product. Normally, a designer has to sit and make one design at a time. But with generative AI, the system can instantly create 10 or even 100 different packaging mock-ups with different shapes, colors, and styles. The designer can then just pick the best one and improve it. This saves a lot of time and effort. Or think about product designs. Generative AI can look at all past designs and then suggest brand new optimized designs that use less material but are stronger, cheaper, and better for the environment. So in simple words, generative AI is not just about answering questions or analyzing numbers. It's about giving computers the ability to imagine and create, just like humans do. Hopefully, you can now see why everyone is so excited about generative AI. It's like having a creative partner who never gets tired and can give you endless ideas in seconds. To understand how it works step by step, first the model is trained on very large data sets. Then it learns patterns and relationships. Next, when a user provides a prompt or input, the system generates completely new outputs that resemble the training data but are unique. Some well-known tools here are OpenAI's ChatGPT, Google's Gemini, and image generators like DALL-E or Stable Diffusion. So we simply seen that machine learning helps systems learn from data. Deep learning refines this using complex neural networks, and generative AI takes it a step further by creating brand new content. In a nutshell, each one is part of the other, moving from learning to reasoning to creating. Hopefully you like this concept, and I believe this is an amazing learning you had today.